Hi, welcome back! In this lecture we are going to write our second OpenGL application as an extension of our first Hello Triangle code. In this lecture I have one key point, that is writing an OpenGL code to visualize a rectangle as a combination of two triangles. For that we will use an element buffer object, EBO, that allow us to index the vertices. Let's suppose we want to draw a rectangle instead of a triangle. We can draw a rectangle using two triangles. After all, OpenGL mainly works with triangles. This will generate the following set of vertices. As you can see, there is some overlap on the vertices specified. We specify the bottom right and the top left vertices twice. This is an overhead of 33%, since the same rectangle could also be specified with only 4 vertices instead of 6. This will only get worse as soon as we have more complex models that have over thousands of triangles, where there will be a large chunks that overlap. What would be a better solution is to store only the unique vertices and then specify the order at which we want to draw these vertices in. In that case, we would only have to store 4 vertices for the rectangle, and then just specify at which order we would like to draw them. Thankfully, element buffer objects work exactly like that. An EBO is a buffer, just like a vertex buffer object, that stores indices that OpenGL uses to decide what vertices to draw. This is so-called indexing drawing, and is exactly the solution to our problem. To get started, we first have to specify the unique vertices and then indices to draw them as a rectangle. You can see that when using indices, we only need 4 vertices instead of 6. Next, we need to create the element buffer object. Similar to the VBO, we bind the EBO and copy the indices into the buffer with the GL buffer data. Also, just like the VBO, we want to place those calls between a bind and an unbind call, although this time we specify G element array buffer as the buffer type. The last thing left to do is to replace the GL draw arrays call with the GL draw elements to indicate we want to render the triangles from an index buffer. When using GL draw elements, we are going to draw using indices provided in the element buffer object currently bound. The first argument specifies the mode we want to draw in, similarly to GL draw arrays. The second argument is the count or the number of elements we would like to draw. We specify 6 indices, so we want to draw 6 vertices in total. The third argument is the type of the indices, which is of type GL unsigned int. The last argument allows us to specify an offset in the EBO, but we are just going to leave this to 0. The GL draw elements function takes its indices from the EBO currently bound to the G element array buffer target. This means we have to bind the corresponding EBO each time we want to render an object with indices, which seems again a bit cumbersome. It just so happens that the vertex array object, VBO, also keeps tracks of element buffer object bindings. The element buffer object currently bound, while a VO is bound, is stored as the VIO element buffer object. Binding to a VIO thus also automatically binds its EBO. We can now put everything together in a code called firstrectangle.cpp, available on Canvas. I can try to show to you the source code, compile it, and run it. Let's get a look at the source code very quickly. We have the usual things. We have here the shader as the strings. We initialize glfw. We compile and link the shaders in one object. Then let's see, where is our point? Yeah, so here we insert the vertices. We provide indices this time, and also we have an EBO here. We generate the VAO here. We create the VBO and we create also the EBO, and then we bind to the VIO. We have the usual things. Major difference here is now we have GL draw elements instead of GL draw arrays. We can try to compile it now. Here. At this point we can run it. And here we go, our first rectangle. One more thing we can try to do is to actually display the two triangles using the wireframe mode. To draw our triangles in wireframe mode, we can configure how OpenGL draws its primitives via GL polygon mode, GL front and back, GL line. The first argument says we want to apply it to the front and the back of all triangles, and the second line tells us to draw them as lines. Any subsequent drawing calls will render the triangles in wireframe mode until we set back to its the default, still using GL polygon mode. So we are done with this lecture. In summary, we developed our second OpenGL application to display a rectangle, using this time the element buffer object, EBO. In the next lecture, we are going to look at the shader GLSL language more in detail. Talk to you in a bit.